How did you begin your career?
Thanks for asking. So it all started in high school. I started early. I wrote a program for my school to teach people Spanish for my Spanish teacher who really loved it, thought it was really amazing, and showed it to some people at a computer company who liked it, and they actually gave me a job offer to work for this company called North Bay Data in Silicon Valley, kind of an entry-level part-time job. But I started in high school, so I started pretty young.
And how did you go from computer programming to DevOps?
Well, I didn't take that path directly. I went as a programmer, and then I worked my way up to an enterprise application architecture, and then I went to become a DevOps engineer, and then I went to become a DevOps manager. I had kind of a strange experience at Intuit. It was a great company, and I had the CTO of Intuit put me on a project with some other architects to design websites that would have zero downtime. And so that was the goal. So we came up with a great design with swim lanes and things of that. And I had done a consulting gig at a nuclear power plant. So I truly believe we could build a website that did not go down. So the team and I came up with this really beautiful, elegant design for Intuit to implement 100% uptime for all their websites. And so a lot of the applications and websites onboarded to the design, but a couple folks didn't, a couple business division had some applications that they didn't put on the design. So I went to investigate and kind of find out, why they were doing that. And it turns out they were still using build docs, and they weren't using things like Chef and Ansible for automation. So they had a difficult time, making a lot of changes to their architecture. So at that point, I kind of felt like I'd become a Glassdoor architect, designing beautiful and elegant things that nobody was going to implement. Had success with it, but some people were holding out, and so for those particular teams, I kind of felt like a fraud. So the next time I had a similar project, with uptime, I really rolled up my sleeves and went to go work with some of these operations groups to get the design implemented. Doing things like Ansible and Chef, and that really caught my eye. I enjoyed it, and so from that point on, I got hooked on DevOps.
What is the killer thing you've done in DevOps?
The killer thing. That's a great question. So, I built an automated pipeline that covers the whole system development lifecycle. In other words, I put everything, and I mean everything, into the pipeline. I had a non-prod pipeline for develop and feature branches, and I had a prod pipeline for release branches. I put everything in there, including the kitchen sink. I had things like monitoring and security checks. I had, three main stages. The phase one was, of course, infrastructure as code, changes to dev to get the infrastructure set up. Then I build the dev branch, and then I would do unit tests. And then I'm a big proponent of putting DB schema changes into the pipeline. So before you would deploy an API that depended on the database, you want to update the database first. So apply the schema changes, look for any data diffs, and make sure that the schema was in place. And then I deploy the API to dev. A big fan of Kubernetes clusters for microservices, so that's where I put the API in this particular pipeline. And then, of course, the website goes to the dev server. And so the big thing that I always put in is post-deployment tests. So you have the build tests and the unit tests, and then the post-deployment smoke tests. So those would run until you had a good deployment. At the end of the whole build process and the deployment to the dev server, I'd send an email to the developer saying, hey, you passed the build, you passed the unit tests, or maybe some of the tests failed, you passed the deployment test, here's the status of that code commit. So they would have, they can go see the code running, and they had a good status report on, what their commits did to the code base. And I also believed in regression tests, so I put regression tests into the pipeline. It took a little bit longer. In the end, I sent those off to kind of an async server that had graphing capabilities that would show the code coverage and things like that. So, but a fan of putting regression tests in the non-prod pipeline. And then phase two was sort of the similar pattern of all the components. But in phase two, I made sure there was automated security tests, and I used things like browser stack. But I was also took it the next level, and when I say about putting everything in the pipeline, this particular application needed to perform well. It needed to load the home pages in under a couple seconds, and needed good performance. So I put in-sprint performance tests where I'd have the CI/CD system call JMeter jobs to run a quick performance test. And so at the end of every sprint, when we run this in-sprint performance test. And then phase 3, this is the prod pipeline where we usually go to staging and prod at this point, but that's the cutting the release branch. And the first thing I would do is the infrastructure as code changes to the architecture. There would be approval process before that to get the sign off before going, and it was kind of set up, not a fully automated approval process, but going to prod, was a good idea to have a approval process, and then deploy the DB schema changes to the database, and then deploy the API to the Kubernetes cluster, deploy the website to the prod servers, and then of course, the smoke tests that run afterwards to make sure there's a good deployment. And now, at the time we didn't have it, but now you can do, automatic verification in your monitoring systems. So I'm doing that now because that's a great thing to have. So I had pipelines at that company for iPhone apps and Android apps, and things like Browser Stack and Sauce Labs are very helpful and handy for that. What set me apart is I always considered continuous testing as part of my DevOps role. So I was a big fan of doing continuous testing and always getting feedback to the developers on the state of the running code and how things were performing.
What is the job of a deployment pipeline?
Yeah, I'm gonna look at my I don't have to look at my notes for that, but think of your pipeline as a job of transporting package codes and artifacts, which is your artifact boat, as fast as possible. So each section of the river has a dock where you add some value, like unit tests or something like that. And so you have all these docks that add value to the process and something new to the boat as you're going down the river. However, the ultimate job of the company is to get the package or the boat downstream as fast as possible. So you want to be careful of avoiding mud banks, and mud banks could be manual processes or political, personal, silos. So you want to try to avoid those. You might need like a single dam if you're in, where quality control is very important. You might want to have a single dam like in the medical industry, and just to make sure there's good quality control check. But you don't want a mud bank every few feet. You want to avoid those. So it's much better to just automate some stops away, and focus at speeding things up by not spending. If you have to make a stop, don't spend much time there. Automate as much of that stop as possible. So speed is important, but also reliability is super important as well. So that's when you need at least one check, especially before you go to prod, and have kind of a manual sanity check before you go to prod.
So how do you move the artifact package or boat faster?
That means do more automation. Definitely want to do more automation. So. I talked about it a little bit earlier, but do your schema changes in the pipeline, and then have maybe an automated backup occur, a couple hours before the main deployment of your database. Automate as much as possible. Schema changes should be automated in a pipeline and definitely should be managed in a repo. It's part of an integrated pipeline. So before updating that API that depends on that database, you want to make sure the database changes get in there. So put the schema changes in the pipeline. If DBAs really want to work in a dark silo, they have to know they're creating a little bit of risk for the company. So the other big thing is to use version control as much as possible. You definitely want to do infrastructure as code. You definitely want to do GitOps, and you want to have lots of deployment tests. And then again, you don't want to keep your feature branches around for a really, really long time because they get outdated. And so, what can speed you up is knowing the difference between the different Git architectures. For large projects with a lot of developers, Git flow is good. But if you have a smaller team and you don't want to do a lot of merging, a branch workflow like GitHub flow is fantastic, and sometimes can be the preference for small teams because there's not as much merging involved. You should definitely have continuous testing. And make the continuous testing easy to operate. I like Nexel, which is a really good framework for testing. And then NUnit, Cucumber, PyTest, JTest, and JUnit are all good as well. And the main thing too is if you're moving to the cloud, don't take any outdated processes, from your on-prem data centers up into the cloud. The goal of the cloud is really to move as fast as possible. You don't want the cloud to become inefficient and slow. So, part of any cloud should be some self-service. And you want to use the cloud to just increase your velocity. So another thing is to do container deployments. That means bake your code into an immutable image. and do very little in the launch and the fry stage of that image, and avoid updates after launch. And you want to do that mainly for the main reason behind that. There's lots of reasons, security is one, but you want to have easy rollbacks. And if you do image deployments, it's easy to roll back to last known good image if you have problems. And so, having immutable images increases speed, increases security, and reduces stress, and it also reduces downtime, which is fantastic. So, if you have microservices, I'm a big fan of Kubernetes. I like Kubernetes because it runs everywhere: Google Cloud, AWS Cloud, Azure Cloud. You can chase, the lowest cost of compute with Kubernetes. And when you combine it with something like Harness, which is good, and Spinnaker, you can have really easy rollbacks. And so, another thing that helps is, some smaller, more frequent releases over big bang releases, and definitely need a continuous feedback loop and always keep your developers in the loop on how the deployments are going. And you can prevent downtime in your pipeline by having really good architecture for your infrastructure. You want isolation, redundancy in your infrastructure to have a good pipelines. Pipelines are only good as the target infrastructure you're deploying to. And so if you're doing cloud computing, that means use availability zones and other high availability techniques. And then finally, focus on time-saving technology, because time recovered can be used for more experimentation, more innovation, or creating new features that generate additional, revenue for your company and additional value to your customers. DevOps is really about increasing the speed of your organization. So, Harness.io, Azure DevOps, AWS Code Deploy, they can help a lot. And I like Jenkins too. And in general, generally there's some good tools out there, but all the tools need to get better. DevOps is still relatively new, and the tools are still getting better and still maturing. And so, I look for some great tools. Look forward to getting some great tools in the future. And I would say one more thing too is DevSecOps is also important. So, security needs to automate. So DevOps is going to take over that role. So if you work in DevOps, engage security really early in the process, and that way there's no surprises kind of like right before you go live. So you want to start, as soon as you deploy to QA, that's when you really want to start engaging the security team and getting their great advice. If you work in security, you're definitely my hero. Some very, very humble advice is at times, more security teams need to automate a little bit more. So consultation doesn't really scale. Humans have limitations, and we don't scale as well as code. So if you have code automated, in your build process, you have automated security checks and more automation, you're going to get more done. So, that's some advice. But, I've worked with the security teams at some great companies that are like super AI. So that advice doesn't apply to a lot of security teams. But in general, great security teams get automation and understand code can be more efficient than consultation, as consultation is hard to scale.
That makes sense. What do super AI security teams know?
I've been lucky enough to work at great companies with great security teams, and they know that least privilege is dynamic. It changes over time depending on the roles people have. It's not something that's fixed in all eternity, and good security teams recognize that. And they will support temporary full admin access for automation. And so, a good thing to do at your company is run a report on how many interactions to the help desk are security related and are due to security policies. I think it's going to be really, eye-opening to see how many tickets come in that are that are the result in the need of a ticket at the help desk, and you'll see that report, and it'll be very eye-opening and really justify DevSecOps. I'm a big fan of DevSecOps. So if you're not working in banking or the military or someplace that requires a ton of security, consider giving developers more access to the system. You don't want to have frustrated developers due to really tight security restrictions if you don't need those security restrictions. So, if you want to deny someone access and you work in security, make that decision on data and not on superstition or some paranoia. Understand, security understands, teams that are really going to understand that read-only rights help create a learning organization, and the more people that have eyes on something, the better it gets. So, you have to be careful with your access control and put a lot of thought into it.
Great. What makes DevOps difficult?
The first point is DevOps is still hard work because there's no magic easy button for building a great pipeline. To build a pipeline takes a lot of manual effort and stringing a lot of tools together. And so the tools need to get better in terms of building pipelines. I like Harness and Jenkins. Other people have preferences for other tools, and I respect that. Octopus is good if you're in a pure Windows environment. I'm starting to like GitHub Actions, but like everything, they're all evolving, and so the DevOps tools need improvement. And so that's one thing that where DevOps is still a little bit difficult. I'd say another thing that makes DevOps difficult is the culture. Culture is extremely important. If the culture doesn't allow a DevOps person access to both the application and the infrastructure, they're going to have a hard time using the advanced features of cloud computing. Cloud computing require full access to the infrastructure and the application to use these advanced features like auto scaling. So a culture of knowledge sharing helps. If you have a culture on knowledge hoarding, that can derail your DevOps efforts. So culture is a top concern. I've been lucky enough to work for some great Silicon Valley companies and some great companies that have phenomenal cultures. And so I've learned a lot by being a part of those organizations.
So how do you fix a bad culture?
It's possible. The first thing you got to know that it is completely possible. It's good to have executive buy-in. That way, if there's people who don't like change or hate change, if you have executive buy-in, you're going to be more successful. So if you bring in too much change, you can get thrown under the bus. So it's important to be respectful of existing systems, and it's important to have executive buy-in to make change. But I think it becomes easy to make a cultural change once you realize that culture is a product of the environment. So environment has a huge impact on culture, and so you can change the environment, which will help change the culture. So that means get those CI/CD servers like Jenkins, buy that software configuration management system, and then train people on the technology, train the DevOps engineers on DevOps coding and DevOps systems, and then the other thing is do some test-driven development, have the operations folks work with software development and work a lot closer with that team. If you do that, you're going to deliver a lot more features for your customers at a much faster pace. So really, to adapt to the modern world of DevOps, you need tool and system sharing, and you also need a culture that supports the gathering of metrics, and a culture that says automation first, and automation is important. So really, my advice is to always be a servant leader and help everyone be successful in their DevOps efforts by doing a lot of knowledge sharing. If teams don't share, you can't have true DevOps, and you probably won't be agile either. Because the immutable patterns and the rolling deployments and auto scaling really require people to give up silos and organize around the work that needs to be done. If a person wants to build a personal empire at the cost of company values and DevOps, there are not that many options. It's fight, flight, or failure. Failure is the worst outcome. So you can actually hold a meeting. What would failure look like if we failed on this project? And that's the worst case scenario, and I think that will help people understand how much misery will be present if the project fails. And so that could increase the motivation of people to adopt DevOps. Silos can destroy your agility and innovation and ability to react to the market. So if you don't address silos, they can really hurt your business over time. I found companies with silos, and luckily most of the companies I work at didn't have a lot of silos, but they will create bland commodities that your competitors can easily replace. It depends on the organization, but I think flat organizational charts are really good. If you have a clear DACIA, who's responsible for what, in a flat org chart, that really tends to improve productivity and create revolutionary new products. Because in a flat organizational chart, people tend to work together towards more broad, meaningful goals. There's a lot more collaborations. You kind of remove the distractions of status politics and competitive, egotistical decision making. So at the great companies I've worked for, they've really, organized around the work and organized around what needed to be done, not some outdated structure from the 1980s. So you want to consider doing like cross-functional product teams or geo-based market teams. And when you think of an assembly line, like a modern assembly line that's very automated, when there's a problem, everybody swarms around the problem and tries to fix it to get the line back going. So that's an example of collaboration to speed things up and get things working again. So in the IT world, like if you're behind on DNS entries and you lost your person who does DNS entries, don't wait 3 months to hire in a new DNS specialist. DNS is fairly easy, so you can get help from another department that needs a lot of DNS entries to create those entries. You want everybody to kind of pitch in where to speed up any bottlenecks that you have. It should be of no surprise that cross training and job rotation create companies that stand the test of time. I've definitely worked for a few great companies that will stand the test of time, and that's because they organize around the work and they do a lot of cross training. Even the founders of our country realize job rotation is important. That's why we have term limits. Often the elimination of a bottleneck requires a lot of collaboration, not further isolation or internal competition. So really bad boundaries can create bad companies. So the suggestion is to really use domain engineering principles to create natural boundaries, ones that make sense, and remove any. Businesses will create a lot of rules, and sometimes you need to reevaluate those rules and make sure they still apply to the problem you're solving or still apply to the business. Do the conditions the rule was created for still exist? If you're finding a lot of rules are outdated, that's when you really want to do a DevOps transformation. And part of that transformation is truly allowing the work to proceed with as little friction as possible. You want to rely a lot more on feedback rules rather than rigid rules, and you want to implement guardrails, not blockades. Got to remove the iron gates and really allow functional teams to be self-sufficient and to succeed.
Wow. What advice do you have for someone just getting started in DevOps? If you could just tell them one thing.
Well, I've been lucky enough to work at some fantastic companies, and I've learned a lot from those companies. And I find that really good companies are great at innovation and great at execution. Execution is really important, really matters. And I find, that action leads to inspiration, and inspiration leads to motivation. So it really all starts with that action, and maybe there's something that you're not really excited about, but then you start doing it, you see something that's really cool, and you get inspired, and that leads to motivation. So really it all starts with action. So the one thing I would tell them is that action equals reward.
Well, thanks for your time, and you have amazing insight in DevOps.
Well, thank you very much. I enjoyed the interview. Have a great day.